So this is going to be back to basics, the 555 timer. Everybody's favorite. Everybody loves 555s, but I don't know if you've actually looked kind of inside a 555 and kind of got a gut feel for what the circuitry is doing inside the 555. Everybody uses those timers and stuff, but I thought it would be good to do. Now I know everybody and their dog has done this video, and there's tons of them out there, and everybody has a different teaching style, so you know, maybe some people like my teaching style better than others, and maybe they'll get something out of it, or maybe I'll say something just a tiny bit different than somebody else. But you know, like I said many times before, I encourage everybody to learn as much as possible, so please watch as many videos as possible. But anyway, this is going to be my take on a 555 and give you some ideas of exactly what's going on. So this is the data sheet from Texas Instrument of a 555. I think it was a national semiconductor part originally, NE555. Anyway, it doesn't matter. So timing from microseconds to hours. And it has a bunch of modes and stuff, so you know, we'll talk about stuff like that. But I want to give you an understanding of really what's inside of the 555 and really what's going on. So we're going to be looking at mostly this. This is a simplified. We'll zoom a little farther. This is a simplified diagram of what a 555 is. It's got a couple comparators. It's got a set-reset latch with a reset. It's got some type of output, and then it's got a weird transistor down here. It's got some resistors and some extra wires and stuff. So let me use my style of teaching, which is kind of like break it down step by step by step, and we'll build it up, and then hopefully people will have a better understanding of it. So what we're going to do is we're going to concentrate on this part of the circuit first, just these three resistors, okay? And those resistors are actually 5K resistors, 5K, 5K, and 5K. Some people say that's how the part got its name, 555. Others say, no, it was just kind of a coincidence. So I'm not sure. Seems too good of a coincidence. So I like to think of it as the 5K, 5K, 5K. In any rate, it's a good way to remember it. 555 means 5K, 5K, 5K. So it's a great way to remember it, even if the story isn't true. So what does that mean? It means that we have a voltage divider here. See, this is VCC at the top, and this is ground at the bottom, and we have 5K, and then 5K, and then 5K. So we're taking the incoming voltage and we're breaking it up into thirds. So this is 2/3 of the voltage, and this is 1/3 of the voltage. And if you don't believe me, we can actually measure it. It's really cool. So let's go a little bit farther over. There's this other wire here that a lot of people never use, which is pin 5. And pin 5 is actually connected to that node right there. So if we have some voltage across here, 2/3 of that voltage will appear here, and we'll be able to measure it on pin 5. So let's do that. Let's get a breadboard here, and I have it already wired up. And so here's our 555, and we're going to input a voltage. There's a couple of things hooked up, so ignore those for now. But we have a VCC going in, and then we're going to measure the voltage on pin 5. Okay, so 1, 2, 3, 4, 5. Here's the voltage. Here's pin 5. Okay, so I'm going to connect my voltmeter here to pin 5. Okay, all right. And then we'll measure that, right? So that's how I'm going to do it. So first we're going to measure the VCC, so we can see if we're actually 2/3 or not. So let's go over here to VCC, which is this pin here. So I'm bringing in VCC on these two wires, and my voltmeters on these two wires. And so this is ground, and this is VCC. So let's measure VCC. So let me rearrange the camera a little bit, because we're going to be doing this on and off. All right, there we go. We're going to use my, my trusty voltmeter here. And what we're going to do is we're going to use the top scale. So 0 to 1 is actually 0 to 10 volts. We have it on the 10 volt scale. So this is going to be 0 volts, and this is going to be 10 volts, okay? And so what I want to do is I want to set this to 9 volts, okay? And it's about there, okay? So we're right about 9 volts. So that's our VCC. Now 9 volts is going to be easy to figure out what 2/3 is. 2/3 of 9 volts is 6 volts. And 1/3 of 9 volts is going to be 3 volts, right? And so let's go ahead and measure pin 5. Okay, so pin 5 is 6 volts, a little more than 6 volts, but 6 volts. Okay, so that is the first node in our circuit, so the 2/3 node, and then the other node is going to be down here around 3 volts, right? So one of the comparators is going to be using this voltage, and one of the comparators is going to be using that voltage. So there we go. So that's because of the 555. All right. So let's take a look at the diagram here. And the next thing is, like I said, this comparator is going to use this node, which is the 2/3 node, and this comparator is going to be using this node, which is the 1/3. All right. And so this comparator is going to be, in our circuit, it's going to be toggling around 6 volts, and this comparator is going to be switching around 3 volts. So what we're going to do is we're going to take this input to this op amp, which is pin 6, and we're going to take this input to this op amp, pin 2, and we're going to tie them together so we inject the same voltage. So our incoming voltage will be presented on both op amps, both top and bottom at the same time, okay? And so let's go ahead and do that. So how do we inject a voltage, okay? So we're going to inject a voltage with a, where's my pen? So we're going to put in a variable resistor. And this variable resistor, I think, is 2K, if I remember right. 2K, it doesn't really matter. So we're going to have plus 9 volts at the top, and we're going to have ground at the bottom, okay? So that's how we're going to generate our test voltage, right? So that's going to come into our part, right? And then the potentiometer is right here, okay? And I can adjust that potentiometer, and I'm going to adjust it high, and an LED comes on. I think you can see that. And when I adjust it low, the LED goes off. All right. So keep that in mind. But let's measure the voltage here on our incoming. Okay. So I think we can see. No, you can't see. Of course you can't see. All right. So here's our incoming voltage. I can turn it all the way up to 9 volts, and I can turn it all the way down to 0 volts. Okay. So this is our incoming voltage, right? So I'm going to turn that on and off, or ramp it up and down, I should say. I'm going to ramp it up and down, right? Now, that first op amp is going to be a comparator, and it's going to act as a switch, and it's going to say, if you're bigger than 2/3 of the voltage, I'm going to turn on. And that bottom one says, if you're less than 1/3 of the voltage, I'm going to turn on. And those will go into that set reset flip-flop, okay? So I'll explain this better, but I just want to get you an idea of this is what's going on, okay? So I think you can see the LED there. Maybe you can point to the camera a little bit, make it easier to see, okay? So I'm going to turn the voltage up. Got to do this without getting my hands in the way. Okay, so I'm going to turn the voltage up. You can watch the voltage come up, and we're going to be watching the LED. So we want to watch both of these at the same time. I'll go slow, and so I'll go up and up and up and up until that LED just turns on. Oh, there it goes. So the LED turned on right there, okay? Now we're going to go the opposite direction. I'm going to turn down the voltage until that LED turns off. And, okay. So I'm going to turn down. So the voltage is coming down. We'll go down and down and down until that LED turns off. So we're going to come down, and there it goes. The LED turned off right there. Now see, conveniently, the 9-volt scale is kind of marked here on this 3-volt scale. So 9 and 3 are kind of in the same spot. So 2/3 of the voltage kind of ends up at 2, and 1/3 of the voltage ends up at 1. So it's kind of convenient here. I can turn up the I can turn it up until we get to about that 2, and then the LED should come on. There it goes. And I can go down until we get to about 1, and then the LED will come on. Okay, so 1/3 of the voltage, 2/3 of the voltage. So that's the 555 resistor chain. 1/3, 2/3, that's the way it works. All right, so if we wanted to do something a little bit different, we could. And that's what the control pin does, okay? So let's take a little bit closer look at this control pin. So what does that control pin do? That control pin hooks up here to the 2/3 node. And what if we put a power supply on that pin 5 wire? Let's say let's put 5 volts there, right? What if we put 5 volts on this wire here? Well, that means that this node will be 5 volts, and then there'll be a 5K to ground, which means that's half. So we can do 1/2. So if we use this leg, we get 2/3, 1/3. But if we inject a voltage directly, then we get that voltage and then half of that voltage. So if we put 5 volts in here, it should switch at 5 volts, and it should switch at 2.5 volts, okay? So let's do that. Let's see here. We need pin 5, which is already here, pin 5. So we need to put 5 volts here. So I need to turn on a separate power supply to get another 5 volts. So just a second, sorry. Okay, so I have 5 volts on this power supply. I'm going to hook up grounds. The grounds are the same. And I'm going to hook up the 5 volts to that pin 5. Okay? So let's see if it does what we think it's supposed to do. Okay? It should switch at 5 volts and at 2.5 volts. Okay? So 5 volts is center of the scale. 5 volts is right there. And 2.5 volts is down. It's down over here, right? So let's then go ahead and adjust it up. And get my hand out of the way. Oh, it just came on. So let me go back down. And I was going too fast. Let's go slower. Slower, slower, slower. And there you go. It just came on. So we switched right at 5 volts. So now I can go back the other way. And get my screwdriver in there. All right, I'm going to come back down. Going to go slow. We're down about 3 volts right here. We'll keep going, and there it goes. It just turned off right at 2.5 volts. Perfect. Okay, so you've probably never used that before. I'm guessing. I never have. So if you use this leg, you get 2/3, 1/3, and if you use this input, you get that voltage and then half of that voltage, so 50% point. So it's just kind of a nice trick to know in case you need to do something like that. It's nice if you have a that you want to switch your 555 maybe on different voltages. You want to set the threshold differently depending on, maybe you have different things going on. And sometimes you want the threshold at one voltage and sometimes you want the threshold at a different voltage. So you can input this into the circuit. Now it needs to be fairly low impedance because remember there's a 5K here to your VCC. So you have to overcome that 5,000 ohm 5,000 ohm resistor. You have to overcome that. But as long as you have a low impedance voltage input here, you can certainly override that 5K easily, and then use these 2 resistors down here. All right. Okay, so we kind of explained these two guys. I kind of I didn't really tell you how this is all working, how that LED turns on and off and everything, but you're getting the idea that we have these 2 comparators, and it's called a window comparator, right? We need to be outside the window. So the window is, in our case, 3 volts to 6 volts. If we're within 3 volts to 6 volts, nothing's going on. That's the hysteresis of this thing. So if you're familiar with Schmidt triggers, they have hysteresis. So this 1/3 section in the middle is its hysteresis. Okay, so we've kind of explained all of this. Now let's explain this part. So we'll talk about the set reset flip-flop. So if you've never seen a set reset flip-flop, there's an R and an S, and the R is set, and the S is set, and the R is reset, right? And then ignore that up there. So a set reset flip-flop is just set, reset, set, reset. Okay. So normally the state conditions of a reset flip-flop are if you hit reset, then the output goes to 0, and if you hit set, the output goes to 1. And then if you hit set, it goes to 1. Hit reset, goes to 0. So it's set, reset, 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 okay? Now, you have to pay attention to these little circles. These little circles mean negative. So the output, instead of, when you do set, instead of it being a 1, it's going to be a 0 because of that negation. That little circle means negating. So if this one fires set, instead of this being high, it will be low. Okay, that's a little bit confusing, but that's the way it works, okay? And then the same with the output. The output is on pin 3, but it has a negation. And so if you take these two combined, then it acts like a normal set reset because that negation and that negation cancel out each other. So set gives you a 1, and reset gives you a 0 on the output, okay? Set 1, reset 0. Okay, now, it also has this funny transistor. So sometimes you want to be able to drive things. So this is a plus and minus totem pole drive. It'll drive high and it'll drive low. But sometimes you want an open collector for certain things. And so this adds also a transistor for open collector. And so when this is low, this transistor is off. Okay. And then when this is high, this transistor is on and pulls things down. So in my case, that's where I've hooked up my my LED. Okay, so I've put my LED in here, and so whenever this transistor is on, my LED lights. Okay, so we saw it when we were high, when the threshold was high, the LED was on. Well, high means reset, which means low, but it gets inverted, which means high, which means the transistor is on, and the LED is on. So that's a bit confusing. So if we went low, then we did a set, which means this goes high, but it gets inverted, so this is low, the transistor is off, and the LED is off. Okay, so that's the way it works. You could also hook it up to pin 3, but since we were driving an LED, it seemed to work better for me this way. Okay, so there you go. I mean, the only thing that we haven't talked about is this thing here called reset. Now, set, reset latches operate on these two wires, right? So if the reset goes high, you go to 0. If the set goes high, you go to 1. And if the reset line goes high, you go to 0. But it has a little circle. So again, it has a negation. So this actually should be not reset. Okay? So when reset is low, that means reset the part. And what does reset the part mean? It means set the output to low. But this is inverted, so it means this goes high. And if this goes high, then this is on. And if this is on, then the transistor is on, or the diode is on, LED is on. So let's try that. Right now, we have nothing on the LED. The LED is off. And if we take our reset line, which is pin 4, so here's pin 4, here's our reset line now. And if I touch it to ground, the LED comes on. Okay, so I've said reset. Independent on what's going on in the rest of the circuit, I've said reset. Okay, so that can be handy. It's like an OR gate. It's like either this or that. Okay. And so we've used the reset. Okay, so I think this is good for part 1. Part 2, we'll start to see if we can't make this thing into an oscillator, because right now we've just done comparison things, which is handy. Sometimes if you just need a comparator, just put this in your circuit. You're laying around, or you need a window comparator. It's great for that. Or you need a comparator that you can input a different voltage on easily. It does that. If you need a comparator that you need a reset on, hey, it's good for that. If you need a comparator that has both a driven output or an open collector output, yeah, I mean, it's got all kinds of building block materials, right? It's not just something that toggles on and off. It does lots of different things.